Hi, welcome to my video on fundamental identities, and the identities in this video is related to what I call the Pythagorean identities. And there's two videos, so this is video 1, Pythagorean 1. And the Pythagorean identity is cos squared a plus sine squared a equals 1. And I'm going to prove this using this triangle. There's a right triangle, ABC, C is the right angle, and C is the angle, so small c is across from it, small a is across from large A, the angle A, small b is across from angle B, the small letters are the sides, the large letters are the angles. So, what we know that cos is SOHCAHTOA. Cos is the adjacent over the hypotenuse, and sine is opposite over hypotenuse. So, cos of angle A, the cos of angle A, here's angle A, cos is the adjacent, which is the B, over the hypotenuse, which is the C. We're going to square it. Sine of angle A, here's angle A, sine is opposite over hypotenuse, so the opposite is the A over the hypotenuse, which is the C, and equals 1. We keep going. So we have b over c squared, so b times b is b squared. C times c is c squared. A over c all squared. A times a is a squared. C times c is c squared equals 1. And we have the same denominator, so c squared. We keep the denominator. We got b squared plus a squared equals 1. We're adding fractions, so we keep the denominator, add the numerators, but they can't add these because they're not the same. And now we notice that to the PYTH, to the Pythagorean property, c squared is a squared plus b squared. In a right triangle, the hypotenuse, the square in the hypotenuse is the sum of the squares on the two legs. So c squared equals a squared plus b squared, Pythagorean property. That means that a squared plus b squared is right here. So that means I can replace b squared plus a squared with c squared because of the Pythagorean. And that means that c squared over c squared equals 1. So this is one of the fundamental identities. Again, another one that you keep in mind. Cos squared a plus sine squared a equals 1. And it has to be the same angle. Angle A could be angle B, could be theta, could be alpha, could be any. So, and let's practice. Fill in the blanks with each. Cos squared theta plus sine squared theta is equal to 1. So notice the angle is theta, so cos squared plus sine squared equals 1. Sine squared x plus cos squared x is 1. So it don't make any difference if you put the cos first or the sine first or vice versa, but as long as you have the square on each of these with the same angle. Number 3, cos squared b plus blank equals 1. So it has to be cos squared. So this is a sine squared, but it has to be the same angle b. Cos squared b plus sine squared b is 1. Number 4, we got a cos squared again of 30-degree angle. So this is sine, and it has to be a square, and it has to be the 30-degree angle to get the 1. Number 5, sine squared 45. To get the 1, got to be a cos, got to be squared, and it got to be the same angle, 45 degrees. Okay, now to prove that again in the special right triangle, and I have a 30, 60, 90, I'm going to fill in the sides and use them to show that this is true. So here we go. This is the 30, 60, 90 right triangle. Opposite 30 is 1, opposite 60 is root 3, and opposite the 90 is 2. Again, this is I'm dealing with the trig, so I'm dealing with, I could have n, that could have been an n, this could have been a 2n, and this could have been an n root 3. These are related to similar triangles. But right now I'm dealing with 1, 2, and root 3 when I'm dealing with trig. So, 60-degree angle. So cos is adjacent over hypotenuse. So the 60-degree angle is here. The adjacent side is 1 over the hypotenuse is 2. Now we got the sine squared on the 60. Sine is opposite. Sine is opposite over hypotenuse. In relation to the 60, opposite is root 3, hypotenuse is 2. So it's root 3 over 2. And 1/2 squared, 1/2, 1 times 1 is 1, 2 times 2 is 4. Root 3 over 2 squared is root 3 times root 3, which is 3. 2 times 2 is 4. And the common denominator is 4, so we'll keep it. And we got a 1 plus 3. And 1 plus 3 is 4 over 4. So it's true. Again, cos squared, sine squared of the same angle will give you a 1. So I proved it in general case up here with letters. Now I also showed you that in the special right triangle. This is still true. And it's still true. This Pythagorean property, the fundamental one, cos squared plus sine squared of the same angle equals 1. Keep that in mind. You will need it when you go to do the identities. So notice I'm doing the first videos, it's just getting you ready to do what students find a little bit troublesome. That's the topic of identities. Now let's derive these. These are more identities here. 1 plus tan squared is secant squared. 1 plus cot squared is cosecant squared. So let's see if we can derive these. Well, let's deal with the first one. Let's deal with number 1. Let's call this number 2, just to keep it straight. So if we take the fundamental cos squared theta plus sine squared theta equals 1, and if we divide both of these by sine squared, we divide both sides, by cos squared. So I'm dividing all parts of this equation by cos squared. That keeps it balanced. Notice that cos squared over cos squared becomes 1. Sine over cos is tan. So it's tan squared. And this is 1 over cos. 1 over cos is secant. So it's squared. So it's secant squared. So 1 plus tan squared is secant squared. Again, if you keep this, when you see 1 plus tan squared, when you're doing simplification or doing identities, if you can remember that as secant squared, it just saves you work in relation to what I'm going to now show you. I'm going to show you, what about if I'm going to do it another way now. Here comes another way. So another way to do it, here I took the fundamental identity, cos squared sine squared equals 1 divided by cos squared, and come up with this. If I took the left side, which is tan squared, and made it sine squared over cos squared, there's the secant. So and because I'm adding fractions, 1 denominator is cos squared. So I'm going to make this cos squared theta over cos squared theta to have the same denominator as this fraction. Because the two denominators are the same, which is cos squared, we keep the denominator and we add these together. So cos squared theta plus sine squared theta. We can't combine them because they're not like terms. But notice, cos squared theta plus sine squared theta is 1. And as a result, we got 1 over cos squared, and 1 over cos squared is secant squared. Because the reciprocal of secant is cos. 1 over cos is secant, so it's because there's a square on it. So notice I derived it by using the fundamental identity divided by cos, come up with 1 plus tan squared is secant squared. Or I took the left side, I call this the left side, and this is the right side. I took the left side and worked it down. Notice I didn't touch this side, and the two of them became the same. So this is proving it. But we'll do more is going to be done on that later. And we have another one that this is number 1 that I worked out. And number 2 is 1 plus tan squared is cosecant squared. So if we take, again, if we take the fundamental identity, which is cos squared theta plus sine squared theta is 1. Now, if I divide all of these by sine squared, keeping it balanced, I'm dividing both sides by sine squared, so I'm really dividing all the terms of the equation by sine squared. Cos squared over sine squared is the same as cot squared theta. Sine divided by sine is 1. And 1 over sine is cosecant. Because it's a square, then it's cosecant squared. And so tan is sine over cosine, and cot is cos over sine. That's one way. Again, another way to do it is to do what I did up here. Go 1 plus cot squared theta equals, and that's cosecant squared theta. So cot is cos squared over sine squared. And the common denominator, there's 2 fractions, but there's only 1 denominator. So the denominator is, oops, let me do this carefully. The denominator for this fraction is sine squared. So I need the sine squared on the bottom, and I need sine squared on the top, because 1 is the same as sine squared over sine squared. Why do I put sine squared over sine squared? Because that's a sine. I need these denominators the same. So that gives me sine squared theta plus cos squared theta all over sine squared. Because the 2 denominators are the same, you keep your denominator and you add your numerator. We can't combine these. But sine squared cos squared is 1. And 1 over sine, reciprocal is cosecant. This is square. Again, proving these two. I did a little bit of work. You're going to see this when I do identities. Or if your teacher has done identities, you'll see this being used, the skill, what I'm showing you here. But you don't have to do it the 2 ways. I'm only deriving them. You will see this. So from now on, when you see these two, that's 1 plus tan squared, 1 plus cosecant squared. When you see these, you'll say, how do I know? Well, remember, tan is, watch this, tan is sine over cos. And my way, because I got 1 plus tan squared, tan, I got sine over cos. Cos is on the bottom, so that means I got to have a secant squared. Because secant is cos squared and tan is a cos. So that's how it come out. That's the way I learned it. And cot is cos over sine. Because sine is on the bottom with cot, then this is sine is on the bottom here. So that's cosecant. Again, it's just my little way of how I learned it. So 1 plus tan squared is secant squared. 1 plus cot squared is cosecant squared. What's on the bottom of tan? Cos. So this is secant. C and an S. And cot, you got a sine on the bottom. That's an S and that's a C. So learn these two. Plus the identity 1, cos squared plus sine squared is 1. So that's the trig identities. You have to learn them. You have to memorize them. Be able to use them. So let's use these to simplify. Here we go. Simplify each of these. Tan plus cot. So tan is sine theta over cos theta. Cot is the reciprocal of that, cos over sine. Remember, tan is opposite over adjacent, which is the sine over the cosine, because opposite got sine, adjacent got cosine. We have two fractions, a common denominator. The LCD is cos theta sine theta. So I multiply this one by sine theta over sine theta. Multiply this one by cos theta, keep it balanced, because that's a 1. 1 times this fraction is this fraction. There's a 1 here. So the two denominators, if you look at them, notice I kept sine on the left, kept cos on the right. So the two denominators are now the same. And multiply, I get sine squared. Sine times sine is sine squared. Cos times cos is cos squared. I have the same denominator on the bottom, so it's sine theta cos theta. And that's sine squared theta, add on cos squared theta. And notice sine squared plus cos squared on the same angle is 1. So I'm just showing you, you have to change the tan to cot to cos and sine. Adding fractions, you need a common denominator. And in the end, a lot of times this will simplify. The math is made up to simplify. So we get 1 over sine cos. Now there's more work I can do, but we'll do more in the identities that you're going to learn sections coming up. B, simplify this. Again, we change cot, tan, secant, cosecant. We change it to cos and sine. Not all the time, but most of the time. Cot is cos over sine. Now PEMDAS says we're multiplying these two, so that's over 1, so that becomes cos squared over sine. So notice I changed the cot. Now I have to multiply before I add, so I multiply these two. A common denominator is sine. There's only one denominator. This is over 1. So I have to multiply this fraction by sine theta over sine theta. The denominator is, common denominator is sine theta. So that's a 1, so I need a sine theta. So cos squared theta over sine. And we multiply here, we get sine squared theta over sine. Notice sine times sine is sine squared. 1 times sine is sine. The two denominators are the same, so we write down one of them. And we get cos squared theta plus sine squared theta. And if you notice, continue down. Cos squared theta plus sine squared theta is 1 over sine. And if I wanted to, I could keep on, I could change that. So 1 over sine, if you could go to cosecant. As an S, I need a C. So you could have 1 over sine or a cosecant. So notice this simplifies to 1 over sine or cosecant. C, let's see, we have to do the divisions first by PEMDAS, P-E-M-D-A-S. We have to do the divisions first before we add. So sine theta, cosecant is 1 over sine. So notice that this is the division here that's happening. And we got cos, or cosine theta. Secant is 1 over cos, again. This is a C, I need an S. This is an S, I need a C. So we have to keep, I've changed them first to 1 over sine, 1 over cos. Now I have to work out my division. So this is sine theta, and I'm dividing here, so I'm going to multiply by the reciprocal, plus I get cos theta, and I multiply by the reciprocal. Remember, I have to do the multiplication division before I add and subtract. I multiply, I get sine squared. I have to multiply, I get cos squared. And sine squared plus cos squared is 1. Again, it works out. But you have to know rational expressions. You have to know getting common denominators. You have to know your identities. Again, repeat. Cos squared, cos squared plus sine squared is 1. 1 plus tan squared is secant squared. 1 plus cot squared is cosecant squared, if you want to memorize some of the Pythagoreans. And you got the tan is sine over cos. Cos is cos over sine. And secant is 1 over cos. Cosecant is 1 over sine. So the quicker you learn them, the easier you begin to do them. Now we have 2 more for practice. And practice means pause the video and see if you can work these out to get a simpler answer. Here we go. Cos squared, tan squared is sine over cosine, so it's sine squared over cosine squared. Cos secant is 1 over c. I got an S here, so I need a c, so it's cos. So notice my first step, I've made changes. I converted tan and secant. Now I do the next step. I got to multiply and divide. So I'll multiply here. I got to multiply these two so they cancel out. So that gives me cos squared. And I got to divide here. So that's cos theta multiplied by the reciprocal, which is cos theta over 1. So that's sine squared. I got to multiply here to give me cos squared. Sine squared cos squared is 1. Again, notice I changed tan and secant to cos and sines. I have to PEMDAS, I have to multiply and divide before I add. So I canceled here to get the sine squared. I divided by multiplying by the reciprocal. So now I got a multiplication. And last, that's a 1. I'm going to add these together. You can't add them, but sine squared plus cos squared is 1. And let's simplify this one. Tan times these two. So this is tan is sine over cos. Sine is okay. And cot becomes cos over sine. Now, I can, several choices. I can simplify the inside first, or I can multiply by, I got two choices here. I can multiply this outside. If I obey PEMDAS, I will simplify the inside by adding these two. Or I can multiply, your choice. So let's simplify the inside. Take time. Sine. I'm adding fractions, so this is cos and sine. So this is over 1. So I need a denominator I'm adding, so denominator got to be sine. So I have to multiply this fraction right here by sine over sine. So sine times 1 is sine. Sine times sine is sine squared. I need a denominator of sine. So sine squared divided by sine is the same as that sine. So I multiply the numerator and denominator here by sine over sine. Now, I still have to do PEMDAS. I'm simplifying the inside first. That gives me common denominator of sine, and I'm combining these. Sine squared. I can't add them together, they're not like terms. Now, I got the inside done. I got them added together. There they are. I can't add these because they're not like terms. I'm multiplying now, so I cancel signs. So that gives me sine squared theta plus cos all over cos theta. And sine cancels. I get those two terms all over cos. And if I wanted to go further, again, I can create two fractions here, but we'll leave it like that for now without causing. Again, identities are tricky, and it's the more you do, the more you learn your skill of adding and subtracting fractions and converting tan, secant, cosecant, and cot to sine and cos. The more you do, the better practice. The more practice you do, the better you get. That's the easy way to say it. And if you like my video, click the like button, click the subscribe button, click the notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.